To use video game language, let's level up, building on one of the exponent properties that everybody knows and loves, that AB raised to the c can be broken apart into the multiple a to the c times b to the c. That exponent distributes across the multiplication between the a and the b. Remembering that property, as well as remembering that an exponent of 1/2 corresponds to a square root, we can write the square root of this number, a to the c, times this number, b to the d, as the square root of the first times the square root of the second, and then we can fiddle with the notation by exchanging the square root sign, the radical sign, for an exponent of 1/2. And so this term right here is a to the c, then raised to the 1/2. Multiply those exponents and you're at a to the c over 2, and similarly here. Okay, so this notation has a lot of curves and detours and also known as's and things like that. So you just have to be able to adeptly go back and forth between the radical notation and the exponent notation. Now, with that in mind, we can do things like simplify this mess. By simplify, we mean, can you boil it down to its simplest expression, perhaps with a numerical coefficient, and then just one instance of a with a certain final exponent, and one instance of b with a certain final exponent. There's multiple different routes through this simplification. There's not a magic way to start. However, I will choose to start by using the parallel to these, except in a quotient structure. If we can take the square root of a product and write it as the product of the square roots, you can bet that if we have a quotient of square roots, we could write it as the square root of the quotient. And that's absolutely true. We can do that. And so I am collapsing the quotient of two square roots into a single square root of the quotient. And now we can start doing some canceling. There's the big square root. How about 9 over 3? Well, that's just 3. How about a to the 5th over a to the 4th? Well, in a quotient, what do? We subtract the exponents. So that's a to the 5 minus 4. And then here, b to the 14 divided by b to the 5th. Once again, we subtract the exponents. And I'm trying to be careful and showing this intermediate step, although it isn't totally necessary because it's pretty straightforward. We get to there. So the square root of 3 times a times b to the 9th. Lots of different ways you could keep going if you needed to. It's sort of an open interpretation as to what's truly simplified here. So for example, we could write this as the square root of 3 times the square root of a times the square root of b to the 9th, the square root of 3a times b to the 9/2, right? There's all sorts of different ways to reconfigure it. This is probably the most straightforward, and then after that, it's cosmetics.